So here's a little update on what I've been up to. I've been diving into type inference. My previous versions of this language have had very haphazard type inference, and I wanted to actually figure out how to do it well so that it is reliable and has supports all of the features that I want in the language. I started out with algorithm J, which is from the Hindley-Milner basic algorithm. There's algorithm W and algorithm J. J is, I think, requires mutation and is maybe easier to implement. I just copied somebody's implementation that I found on GitHub. And then there's HMX, which is first described in this paper, I guess, in, what was this, 1997? And it kind of does the same thing that Hindley-Milner does, but uses a system of constraints, which I still don't totally understand kind of what constraints are doing and how to take advantage of them. But I found somebody that had implemented it in Haskell or OCaml, and I was able to port it over, and it produces the same types as algorithm J, but is potentially more extensible if I can figure out how to do that. I really want a row polymorphism though. So extensible records and extensible variants, like OCaml's polymorphic variants, or Elm or Rock both have extensible variants, and I want that. So I found a paper that does kind of outlines a way to do that with kind of a very minimal extension to classic Hindley-Milner. And luckily I found somebody who had kind of implemented that with algorithm W as the base and adding on the constrained rows. So I got that going and was able to get some of the features I wanted from polymorphic variants and records, but it couldn't do recursive types. So a list that, you've got a tail and a head, cons and nil, it can't infer that, does an occurs check, which I'm thinking maybe I can use the constraints from HMX somehow to represent polymorphic records and variants differently, but not sure about that. I also ported the algorithm from this paper, the essence of ML type inference. There's a tarball that they include of the source code for all the OCaml corresponding to this, and I just did kind of a straight across port of the OCaml. But this is based on HMX, and it is using constraints for some things, but it doesn't have polymorphic records and variants in the tarball, and they talk a little bit about how to do the constrained rows approach, which I ended up kind of porting over from this one into Mini, which is the essence of ML type inference paper implementation. So kind of same amount of power here. Their type inference algorithm is much more extensive. It'll do mutual recursion and some other stuff that I haven't really bothered with yet. But still doesn't do everything I want. And crucially, one thing I want in this language is type classes or something similar. Rest traits, something that can make it so that I can have numbers that that can be a little flexible, have a plus function that can take an integer or a float or whatever else. And other things besides. There are a lot of uses for traits or type classes. So I went ahead and made my way through the Typing Haskell in Haskell paper, which is extremely well written and was very easy for me to read, even though I have very little background in kind of the formal semantics stuff. Obviously, I was translating Haskell into TypeScript, but got all the way through that, which gives us type classes. You can see I'm, not showing these as Haskell syntax, but hopefully it's readable. Function, we've got this a type variable that has to have an instance of the num class in order for plus to be usable, and we can see here that it infers that this is going to be double. But if we just have integers, it infers int, which is nice. So that was just kind of basic gut check to make sure type classes worked. I went ahead and again brought over the same kind of constrained rows approach from the algorithm WCR and Mini into this type algorithm. It involves adding a separate kind that is a row kind that's kind of parallel to star, and then unification gets a little bit more exciting because you have to go through both records to ensure that you don't have collisions in the labels. You can see if I try to do x1, x2, there's a repeat label. Anyway, but we've got the kind represented here to say that A is a row type, and you could combine that potentially. Anyway, but the problem is we still can't do recursive variants because there's this occurs check. And I haven't yet tried just disabling the occurs check, but you would need to have a way to back things off, like figure out how to represent the recursive type. And I haven't figured that out yet. I'm thinking I might just kind of look at the rock source code and see if I can port their type inference algorithm as my next step to see how they do what they do, and see what parts of it I want to keep. But that's where I'm at. This has been very interesting, and I've learned a lot about how to read kind of esoteric notation, and made a lot of progress.